This is elastic cord or elastic string, it is called as. So what is the time period of oscillations of this one? So you displace this block. So there's a cord, no? So there's a string. So it will get elongated. So then what is a K? So K depends on Y, A and L naught. L naught is natural length. I think you go back to elasticity, the spring constant of a spring. Similarly, the elastic string also. I think rubber band, you might have come across rubber band. That rubber band is what we are discussing, you know. So it is being elongated and I release it. So spring force will act similar to that. Then when it comes to mean position, don't show spring. It's a elastic string. It is string. I think you must try to elastic string and spring are different. What is the difference, sir? Both are elastic bodies. Okay, you can see now. This will have maximum velocity. I elongated by a distance c. And when it comes to mean position, it will have maximum velocity. After this, what will happen? What can happen to the string? String will become loose. Rubber band, all of you, especially girls, for to tie to knot your ears, you use some sort of elastic bands, no? That is what elastic string or elastic band it is. Can it undergo compression? Elastic rubber band or elastic string, it cannot undergo compression. It can undergo elongation. Elongation possible, but no compression. Am I right? Spring can undergo compression. Say like, sir, I'm not seeing spring. Okay, well, some pens will be there, no? In the pen, small spring will be there. Or if you have a bicycle, spring will be there. Or if you have a bike, for that, for the stands, no? Side stand, spring will be there. Okay, do notice that that's called spring. And this is elastic band. The elastic string best example is elastic band. So what is this? This will be loose. When it's a loose open, no question of any elastic force will act here. The moment what will happen, when it comes to mean position, very next moment as it starts moving towards left, it'll become loose and it will continue to move with a constant velocity. Tell me like what will happen to this block? This block will go, collide elastically with the wall and returns back. At the most that can happen. So here what will happen? It is not SHM. Here it is SHM. Here open uniform velocity motion. So further what will happen to block? It'll collide. And finally what happened? It will come back to again mean position. Is it SHM? No, only half of the part is SHM. The remaining half is not SHM. No, again, the elastic band, what will happen to it? It will get elongated. Then again, the spring force will make it undergo retardation, comes to maximum elongation, then returns back. Here it's not SHM. It's a uniform velocity motion. So what is the motion here now? Here SHM, here it's a uniform velocity motion. Agree this? The motion will be. So this particular path, how it will be? It has started here. So what you should call this as uniform velocity. This is what SHM. Okay, this is what happens. I think the elastic strings, if it is a spring, okay, then again, left part is also will be SHM. Fine. So these are the, you have to be very, very careful. I'm telling this one. It's not that, you have to be alert. That's what, nothing big. So you can manage all these questions. So you should be extra alert in conditions given. Okay, let me give elastic string, and I do have a block, and this is spring. Elastic cord element, both are same. This is spring. In this case, what happened to time period of oscillation? I think you have to be careful. When the block is on the right hand side, what are the spring forces that will be acting? This will get elongated. And what about this? Compressed. So here we'll get force in this will be, I'll make symbols little bit different so that you can notice it. Let this be K1, let this be K2, spring constant. What are the forces? K1x, and this is compressed, no? So the compressed force, I'll show it here. K2x. I get this when on the right hand side. On the left hand side, when it is on left hand side block, somewhere here, let me. This is elongated. What about the elastic cord? It will be like this. It will be loose. Okay, for half of the time period here, both the spring forces will come. Remaining of time period, only the spring force will come. So what is the total time period? How to calculate T1 and T2? What is TA? In the right of, it will be effective spring constant. I think they're in series. Am I right? Or they're in parallel? They're in parallel, no? Effective, you should write K1 plus K2. Am I right? If they're series, different elongation should, they're in parallel. So therefore, the total time period of oscillation will be time period right plus time period to the left. What should be this one? Off of it. So pi by m by effective spring constant K1 plus K2. Pi m will be only K2. This is a time period. Able to understand this one? The cord, elastic string, both are same again. Rod can undergo, elastic rod can undergo the compression. I think